Hey guys, so in this video I wanted to go over the review for lesson 2.1, 2.2, and 2.3. It is unit 2's review. And I wanted to do a little bit different video instead of just doing it on my iPad so you can see kind of the process if you are using a calculator to try to solve these. So I'm going to do a few. The rest of them I will go over in the live classes, either Wednesday or Thursday. So if you get to number 1 and you say, okay, well, I don't know what times what is 21. So I'm going to come in here and say, okay, what's the smallest number that can go into a 121? Well, I'm going to get my calculator out. And I'm going to do, okay, 121. Can I divide it evenly by 1? Yes. But if I do 1 times 21, I'm still in the same boat of trying to find what times what is 21. So I'm going to keep going. 121 divided by 2. Well, that gives me a decimal. That doesn't mean, or that means 2 does not go into 121 evenly. So I'm going to keep going. Still gives me a decimal, so I'm going to keep going. I'm going to keep going until I get a whole number. Still no. 7. Typed it in wrong. 7 is not it, so I'll keep going. I still get a decimal. So 121 divided by 8. Still did get a decimal. Still get a decimal. Still get a decimal. And there's our first whole number. So we're going to have 11 times 11. So we all agree, hopefully, that 11 times positive 11 gives us positive 121. Well, we can also do negative 11 times negative 11 to give us positive 121. So we're actually going to have plus or minus 11 as our answer. So what if we have something closer to number 6? Remembering that that smaller 3 as our index is telling us how big of a group we can put together and move out from underneath the radical. 120 isn't a perfect square. So we're not going to worry about finding 2 numbers that can multiply together that are the same to get that number. We're going to factor tree it out. So we're actually going to take the cube root of 120 and separate it out. Well, it ends in a 0, so I know it's an even number. So I'm going to come to my calculator and do 120 divided by 2. I get 60. So I get 2 and 60. 2 is prime, so I'm going to circle it. 60 isn't a prime number. I can divide it multiple ways and still get a whole number. Prime number is you can only divide it by itself and 1 and get a whole number. That's the only options. 60, smallest number we can go into it is 2, so I'm going to go with it. So 2 and 30. 2 is prime, 30 is not. So I'll keep going. 30, I'm going to put in my calculator. You can use your calculator as much as you need to. 2 and 15. So I've got 2 and 15. 2 is prime, 15 is not. 15. What times what is 15? Well, 15 divided by 2. 2 is not going to go into it. It's an odd number. Let's try 3. 3 and 5. 3 and 5 are prime. So that means for our cube root of 120, we've got cube root 1, 2, 3 2's, 2, 3 2's, 1 3, and 1 5. If you don't believe in this method, you can always check yourself once you get to this point. You're going to multiply all of your prime numbers together and see if you get that 120 back. 2 times 2 times 2 times 3 times 5. got that 120, my prime factorization was correct. So then I'm going to group 3 of the same thing together and move outside of the radical. So because of the 3, I can group 3 2's together and move outside of the radical. So I get a single 2. And then the 3 and the 5. The 3 does not have another 3 to group with it, or 2 other 3's to group with it. So it stays underneath the radical. The 5 also does not have 2 other 5's to group with it, so it stays underneath the radical. So number-wise, I have 2 times the cube root of 10. Now, with the x to the 7th, we're going to have, now you can do it the long way. Go for it if you really want the long ways. You're going to have 7 x's. 2, 3, 4, 5, 6, 7. And you're going to have to group 3 together. So 1, 2 x's are going to move out. So x to the 2nd, and then the lonely x on the inside. Or you can do, the trick would be, you want a number divided by 3, multiples of 3. So you would have x to the 6th, x to the 1st, and then you could do that 6 divided by 3. So that would be your outside exponent. If you really want to do the shortcut. So your answer for number 6 would be plus or minus. Gonna have a radical. We've got, and I'm trying to color code it like I did in the live sessions. Number wise, that's purple. Sorry guys. We've got 2 on the outside. Not a cube root. Then on the inside we've got a 10. And then for x's we have an x squared. And then we have a just x on the inside. So this whole thing right here would be our answer. Going on. For number 7, we've got a fraction and we're trying to fraction with the radical and we're trying to put it in exponent form. So first, I only care about the denominator for now. So 2x to the 3rd, y to the 6th. Things that are understood that you cannot see is that our index is 2 and our exponent with this 2 is 1. So 2 to the 1st power is there. So to get this out of the radical into exponent form, we're going to take our bases of our exponents and put them on the outside. Then we're going to take our exponents and keep them with our bases. So 1, 3, and 6. And then our index is going to go as the denominator of all of our exponents. Now, essentially, that is all we have to do for the denominator. If you see that you can simplify one of the exponents, you can. So we would have 2 to the 1 over 2. And you would have x to the 3 over 2. Then you would have y 6 divided by 3 is 2, so you would just have 2. So 1 over that 2 1/2 x to the 3 over 2 times y to the second. Then we want all of this from the bottom to go to the top. So all of our exponents are going to become negative in that step. So 2 to the negative 1/2 x to the negative 3 over 2 and y to the negative 2. And that would be your answer. So what if we were asked to go the other way? So what if we started with a negative exponent? You can do it multiple ways. I'm pretty sure I've gone over different ways in the law of classes. You can go ahead and take care of this negative. You can go ahead and say 1 over 4x to the positive 3 over 4. You can go ahead and do that. Or you can deal with it as a negative and then handle it. Does not matter. So our base is 4x. So we're going to have a radical. That 4x is going to come on the inside. The numerator of this is going to stay with the base. And the denominator of this is 4. It's going to go on the outside of the radical. So this would be our answer. All right. Going on to exponent properties. If we were given this, we have a power to a power. So what I like to do is think of it like distributing that power on the outside. So we would distribute. So we would have x to the 1/3 times 0. Still that multiplication in between for now. 3 over 6 times 0. We would simplify, so x to the 0 power times x to the 0 power. Once we're multiplying, we are adding our exponents if the bases are the same. So we have x to the 0 plus 0, which is the same thing as x to the 0 power. Now, anything to the 0 power just equals 1. Anytime, all the time. As long as it's to the 0 power, the answer is 1. Then we're asked to do the inverse operations and solve for x. So in this case, we can use our calculator. Again, the reason why I'm using my phone versus the iPad is so I can walk you through those steps. So I want to move that 2 to the other side. So I'm going to subtract 2 on both sides. The reason why I want that radical by itself is because I have to take it to that power of the index. So it's got to be by itself. So I'm going to do 2 subtract 2, which is 0. So that cancels out. Cube root 5x minus 2 equals, well, 4 minus 2. Hopefully you don't need the calculator for that, 2. Then we got to take this radical to the power of the index. So we're going to do third root. What we do on one side, we've got to do to the other. So we're going to get 5x minus 2. And then we're going to go to our calculator. We're going to do 2 caret key 3. And that's what it should look like. Hit enter and you get 8. And then you're going to keep going because x is still not by itself. If you want to box it in, circle it, do whatever you need to. That's our goal, is to get that box by itself. So we're going to add 2 on both sides. Negative 2 plus 2 cancels out. We're left with 10 equals 5x. There's multiplication in between that 5 and that x. So we're going to divide by 5, divide by 5. X equals, well, if you need to, 10 divided by 5 equals 2. And that would be your answer for number 5. Number 9. So, number 9, our radicals are by itself. So we've got to realize our indexes are 2, or understood 2. So to get rid of the radicals, we're going to square both sides. So now we just have 2k plus 40 equals negative 16 minus 2k. So I'm going to get the 2's, or the k's on one side. So I'm going to move the k's to the left side. So I've got to move it by addition because it's subtraction or negative. Negative 2 plus 2 is 0, so it goes away. I'm left with 4k plus 40 equals negative 16. Then I've got to move the 40, so I'm going to subtract it. 40 minus 40 is 0, so I'm left with 4k equals, if you need to use your calculator, use your calculator, negative 16 minus 40 gives me negative 56. There's multiplication in between the 4 and the k, so I'm going to divide by 4. 4 divided by 4 gives me 1. 1 times k is the same thing as just k. Equals, I'm going to go to my calculator, I'm going to just hit divide, and it pulls up that negative 56 from the previous. Divide by 4. So I get negative 14 as my answer. Alright. So, number 2, well, I didn't switch the numbers, I'm sorry. Number 2 for the second graph, we have, there we go. We have to determine our shift description. We have to remind ourselves what the parent function is. We're going to create a table and graph. So I'm going to try to color code it as best as I can. The 2 is on the outside. There's multiplication in between that, the 2 and the radical sign. This is going to determine if we're compressing or stretching. So it is above 1, it's greater than 1. So we are stretching. Our plus 5 is on the inside. It's affecting the x's. So we're going to be disobedient to the sign. So we're going to be moving to the left 5. Then we've got a plus 1 on the outside, out back. It is obedient because it's on the outside affecting the y's, so we're going to be moving up 1. So with this, as soon as you create your shift descriptions, don't worry about the equation anymore. Don't worry about the equation anymore. So the parent function is y equals square root of x. So we're going to create a table for that. So y equals square root of x. So my numbers that I use in all of my problems for these is -1, 0, 1, 4, and 9. My y values for this, you can put it in your calculator and find them, and we can do that. Go to y equals, erase what's there. The square root is right there, so you're going to have to hit second x squared to get that square root symbol. We're going to hit x, we're going to do second graph to get to that table, and there are your points. The reason why I picked these points is because they're whole numbers for the parent function. If I chose 1, 2, 3, 4, 2 and 3 have very long decimals I don't want to deal with. So at -1 it's error, 0 it's 0, 1, 2, 3. Alright, so the first transformation we're dealing with is that stretch. There's multiplication, it's on the outside, it affects the y's. So this transformation, so stretch, due to the stretch, we're going to come in here and multiply by 2, multiply by 2, multiply by 2, multiply by 2, multiply by 2. Our x's stay the same. Nothing with the stretch is affecting our x's. So we have error times 2, still error. 0 times 2 gives us 0. 2 times 2, or 1 times 2 gives us 2. 2 times 2 gives us 4. And 3 times 2 gives us 6. So that is what our stretch does to our parent function. Next table, we're going to look at what the stretch did. So the same table, so we're going off of this table, plus or and our left 5. So our left 5 was on the inside. So if it's on the inside, our y's are not going to be affected by it. So it's still this error, 0, 2, 4, and 6. Left 5, moving our x's to the left means we're going to come in here and subtract 5 from all of our x values. So we have -1, subtract 5, which gives us -6. 0 subtract 5 gives us -5. 1 subtract 5 gives us -4. 4 subtract 5 gives us -1. And 9 subtract 5 gives us +4. So that would be our table if we were stretching and moving left, and that was it from the parent function. Now what if we were doing all of it, all of the transformations? So if we were stretching, if we were moving to the left 5, and moving up 1. So that up 1 was on the outside, affecting the y's. So if we want to move our y's up, we're going to add 1 to all of these y values. Our x values stay the same because that +1 on the outside did not change them. So we have error +1, still error. 0 plus 1 is 1. 2 plus 1 is 3. 4 plus 1 is 5. And 6 plus 1 is 7. So that would be our final table. This would be our table for the equation that was given. So we can graph these on the graph. Our parent function was 0, 0, 1, 1, 4, 2, and 9, 3. which is there. And our new graph is -5, 1, -4, 3, -1, 5, and 4, 7. So there is our new graph. Alright, remember if you have any questions, email me or ask it during the live classes. Thanks.